Hello, my name is Mrs. Salinas-Flores. I work at San Antonio College, and today we'll be working out a math problem from Messer-Smith Intermediate Algebra, specifically from Chapter 7, Section 6, problem number 45, and it reads, an object is launched upward with an initial velocity of 96 feet per second. The height in feet of the object after t seconds is given by this function. H of t is equal to negative 16t squared plus 96t. Now, I'm a visual type of person here, so I'm actually just going to draw an object. I'm just going to say it's a square or a box or something, and it's tossed up into the air, and we know at some point it's also going to come back down, okay? So it just kind of gives you a visual image of what we're talking about. Now, this function right here is going to be very important to answer the following questions. The first one being A, from what height is the object launched? And how do we find that out? Well, we have to solve in our function the height when the time is 0. So we're going to solve h of 0. And I like to build what I call a skeleton. Anytime I'm going to put a value in for a variable, I put parentheses wherever that variable is in my formula. And then I substitute in. So they want 0 in for time, so I'll put 0 here and 0 here. And then we solve. And you'll easily see that h of 0, once you simplify this side over here, well, these two terms are both being multiplied by 0. Therefore, h of 0 is 0. What does that mean? That is the height of which the object is actually launched. So you can put your answer as 0 feet. Okay, so it starts literally from 0 feet. So let's just say from the ground right here. Okay. B, it says, when does the object reach a height of 128 feet? So at some point, it will reach a height, let's say here, just for example purposes. Let's say right here is 128 feet. It didn't say that the peak of the launch was 128 feet. It just said at some point it will reach a height of 128 feet. And they want to know, when does this happen? So what we have to do is substitute in for h of t 128. And then we fill in here the rest of our function. So I've got negative 16t squared plus 96t. All right, so let's go ahead and solve here for t. And remember, that'll give us the time that the object reaches a height of 128 feet. So the very first thing that we need to do is set our equation equal to 0. And I'm going to do that by subtracting 128 from both sides. So when I subtract 128 from the left-hand side of the equal sign, I'll just end up with 0. And when I subtract it from the right-hand side, you'll see I'll have negative 16t squared plus 96t minus 128. And now we need to factor this trinomial. And the first step in factoring any polynomial is to see if there's a greatest common factor, also known as the GCF. And this one does have one, and it happens to be negative 16. So we're going to factor out negative 16 from this trinomial. And we are left with, inside the parentheses here, t squared. And negative 16 times, we'll say, let's see, we've got negative. It has to be a negative 6t, because a negative times a negative gives me that positive. And then at the very end here, negative 16 times what gives me negative 128. And that's going to be a positive 8. And now all we have to do is factor out the trinomial that's inside of the parentheses. So we'll just move our work over here. So I'm going to have 0 is equal to negative 16. And we're factoring this trinomial here, and we can use what's called the key product key sum method. And that just simply means finding out the key product of the trinomial that you're trying to factor, And that's found by multiplying the coefficient of the first term and the coefficient of the last term of actually the polynomial that you're factoring inside of the parentheses. And if you multiply those two coefficients together for your key product, that would be 1 times 8. You'll see that'll end up with 8. And our key sum is simply the coefficient of the middle term, which is going to be -6. And so, to save time here, two numbers that multiply to get a +8 but add to get -6, those two numbers are going to be -4 and -2. Because when you add them, they'll give us both our key sum, and so they work for our key product, work for our key sum. So I'm getting ready to now open up the two sets of parentheses that I'm going to need to factor this trinomial. Here we go. Here's my two sets. And using the numbers from my key product and key sum, I can fill in my two parentheses. And I've got the two numbers of -4 and -2, because -4 and -2. And I'll erase this just so it looks a little bit cleaner. So that means I'm filling in my parentheses. I've got t here and t here, and then a -4 and -2, so I'm going to put -4 and -2. Continuing on with the solving of this, we're going to have to set our two parentheses now equal to 0. So now we have our time -4, or t -4, is equal to 0, or t -2 is equal to 0. And you'll see here that when we solve for t equals 4, or t equals 2. So that means that just answered the question, when does the object reach a height of 128 feet? And you might be asking yourself, well, why do we have two answers? We have 2 seconds and 4 seconds, right? Well, it reaches 2 seconds after it's first launched into the air. It reaches 128 feet after 2 seconds, but then, remember, the object keeps going, reaches its peak, and then will hit 128 feet again on its downward descent. So that's where we get the 4 seconds. So at 2 seconds and at 4 seconds, our object will be at 128 feet. C says, how high is the object after 3 seconds? So now they're asking us, what is the height after 3 seconds? So we're using our function that they gave us, h of t, but we got to solve for h of 3. They want our time to be 3 seconds. So what I'm going to do is build my skeleton, which means, remember, parentheses in for my variable t. I'm using this up here, plus 96t, and in goes 3 and 3. Okay, so here we go. H of 3 is equal to, and I've got -16 times, and then 3 times 3, we've got to figure out this exponential expression here, simplify it, which is going to be 9. And then plus, and then we have 96 times 3, which is going to be, this is going to be 288. Okay, so now we have h of 3, which is equal to -16 times 9. That's going to be a -144. And then we have plus 288. And we're almost at our answer. H of 3 is equal to -144 plus 288 is a +144. So our answer here for how high is the object after 3 seconds, it would be 144 feet. All right. Now for our final question, it says, when does the object hit the ground? So now they're asking us when the object is at 0 again, right, at a height of 0, what time are we talking about here? So in goes 0 for h of t, okay, into our function here, h of t, And now we have to solve, when we have h of t equaling 0, what is our time? So this equals negative 16 t squared, and then plus 96 t. And we just simply solve this here. We're solving for t. We factor out the greatest common factor. So we'll start off with factoring out a negative 16t, and we end up inside the parentheses. We'll have, if we factor out a negative 16t, we are left with t, and then minus and negative 16 times what gives me, times a negative what gives me 96. That's going to be, let's see, 6. Okay, perfect. So now we have negative 16t. That's our greatest common factor, and what's left inside the parentheses is the quantity t minus 6. Now we're ready to set these two factors to 0. So that's got negative 16t is equal to 0, or t minus 6 is equal to 0. So if we divide both sides on this first one here by negative 16, you'll see that t equals 0, or, and if we solve t minus 6 equals 0 for t, you'll end up with t equals 6. Now, we have two answers, but let's look at the question here and see if one of these answers or solutions is an extraneous solution. And it says, when does the object hit the ground? Well, it's definitely not going to be at 0 seconds, because that's when it's actually launched. They want to know, when is it actually going to launch up and then hit the ground after it's launched. So it has to be 6 seconds. And that is how we work out problem number 45 from the Messersmith book.